Okay, so here we've got lithium, and this reacts with HCl, so hydrochloric acid, and it produces lithium chloride and hydrogen gas, right? And so we've got to calculate the volume occupied at room temperature and pressure by hydrogen gas, by the hydrogen gas produced by the reaction, right? We've been told that the HCl is in excess, right? So therefore, from that we can infer that the limiting reagent is the lithium, right? So that's going to determine the amount of substance of the hydrogen gas produced, right? Okay, so but in order for us to actually work out the amount of substance of hydrogen gas produced, we will get to the point of using this balanced equation, but the first thing we want to do is work out the number of moles of lithium that actually reacted, right? And the equation we're going to use is that the mass is equal to the moles multiplied by the molar mass, right? Which in other words is that the number of moles is equal to, and what I'm doing here is just dividing both sides by the molar mass, but that the number of moles is equal to the mass divided by the molar mass, right? And so we have this value, right? So that's 8.95. But we don't really have that just yet. We can work that out from the periodic table. So let's go ahead and do that. So as you can see, lithium, we've got relative atomic mass of 6.9. So we can say that the molar mass of the lithium, because it is just elemental lithium, effectively lithium is equal to 6.9, right? And that's going to be in grams per mole, right? Okay, so that 6.9 is going to be the molar mass, right? So therefore the number of moles of the lithium is going to be equal to, in effect, 8.95 divided by 6.9, right? So if you work that out, which I'd invite you to have a go at, I'm going to round this, but if you do work that out, you're going to get 1.2971001, and I'm going to round this down, right? So it's going to be a 4 here, so, and I'm just going to leave it at that, right? So okay, so with this, this is going to be in moles, right? With this value, we need to take a look also at, well, when we consider the balanced equation, what's going to be the actual number of moles of hydrogen, right? So what we can see is there's a coefficient of 2 next to the lithium, and there is effectively, you can say no coefficient, but really the coefficient next to hydrogen is a 1, right? It's just, when it's a 1, you don't need to write the 1, right? But what does that tell us? What that tells us, if we put together a comparison ratio, so the moles of lithium compared as a ratio to the moles of H2, right? We can say that for every 2 moles of lithium, we're going to get 1 mole of H2, right? And so if we try and get this side down to 1, we can effectively say that for every, well, we divide both sides by 2 to do that, right? So divide both sides by 2. We can say that 1 now is going to be, for every 1 mole of lithium, we're going to have effectively 0.5, right? Which is the same as half. 0.5 moles of H2, right? And the implication is that the moles of H2 is equal to 1/2 multiplied by the number of moles of lithium, right? Which is just why I've said it, but in other words. But the implication, as far as the numbers we actually have, is that we can use the number we just worked out to work out the moles of H2. So, which is going to be equal to 1/2 multiplied by the value we worked out here. So that's going to be multiplied by 1.2971014, right? And so if you have a go at working that out, you should find that you get 0.6485507, and that's going to be in moles, right? Okay, so here's the thing. We now need to use this value we've got for the moles of hydrogen to work out the actual volume that hydrogen occupies, because we've not been asked to work out the moles of hydrogen, we've been asked to work out the volume occupied by the hydrogen produced from this reaction. So in order to kind of achieve that goal, what we need to do is, well, if we know what the question tells us, so it tells us that what we're looking for is at room temperature and pressure, what is the volume occupied? And we are told that 1 mole of any gas occupies a volume of 24 decimeters cubed at room temperature and pressure, right? So what this tells us is that for every 1 mole of, in our case, H2, that's going to occupy 24 decimeters cubed. And so to work out how much volume occupied by this specific number of moles we have, we just multiply it by 24. So what we can say is that the volume, so we can say the volume of H2 is going to be 24 multiplied by 0.6485507, right? And yeah, if you have a go at working now, that's going to give you 15.5652168. Yeah, and that's going to be in decimeters cubed. Yeah. Okay, so the thing is, our question asks us to give our answer to as you can see, to a maximum of 2 decimal places, right? And so this needs to be given to a maximum of 2 decimal places. So in order to, we need to round this, so that would effectively be 15.5, we'll just round it up to, right, so 57 decimeters cubed, and that's going to be to 2 decimal places, right? So this would be effectively our volume of the hydrogen, right?